Alright guys, so the lesson for today is going to be relatively quick. We reviewed writing equations of lines on the last lesson, and we're still going to be doing the same thing with this lesson. The only difference here now with this lesson is we are going to be looking at scatter plots and best fitting lines. So really essentially today you got basically two definitions. First of all, the first definition is a scatter plot. So what do you think a scatter plot is? If you said what you see on the screen, you're exactly right. Notice that the points look like they are scattered across the paper. That's a way to think about it. Each one of these points, though, represents something specific. In particular, this example that I've given you today is the age of a person here and the resting heart rate over here. So you can see in general, hopefully, that as the age goes up, the resting heart rate tends to go down. And so that tendency, or trend we call it, creates a pattern. Specifically in this case, linear pattern. Notice the points have a slope to them. And that is how you know it's linear. It can be approximated by a line. It's not going to be perfect because obviously these are not packed together really tightly, but these points follow a linear shape or a linear pattern. And so what we have is the other concept that we're going to talk about today called a best fitting line. Or sometimes you'll see that called a regression line in your more detailed math classes. So this is a best fitting line. What do you think a best fitting line is defined as? Let's think about it. Best fitting line. Oh, it's a line that fits the best. Yeah, it's a hard one. A best fitting line is what we're going to draw. Now, obviously, if I want to go through and I want to draw a best fitting line for this particular graph, I'm going to use a nice little light blue color here. I'm not going to draw something down here. That doesn't fit all the points the best. I'm also not going to draw something right here. Even though technically that is in the middle of the points, that's not a best fitting line. Same thing with this one. That goes right through the middle of the points, and it even hits a couple points. But that is not the best fitting line. To be a best fitting line, it has to fit the points the best. So think about a line. Two things it has. A line has a slope and a y-intercept. So the slope and the y-intercept of this line should match the slope and approximately where the y-intercept would be, technically if you think of it that way, for this particular line. So you're going to want something that goes probably down through the points, I'd say probably like this. Now, is that perfect? No, I wouldn't say that's perfect. But it's a pretty good approximation of what the points are doing. It follows the slope, and it's through the middle of the points. You got some of the points on the left side of the line, some on the right. You got some above the line and some below, if you want to think of it that way. But it fits the best. That is the best fitting line. Now all I've got to be able to do is find the equation of this line. So not only do I want to be able to draw the line, I want to be able to find the equation. Well, what's the two things I need, just like I've used over the past few classes, even before spring break? I want to find the slope, or the m, and the b, or the y-intercept. The slope and the y-intercept, the m and the b. The y equals mx plus b. So first of all, let's find the slope. I'm going to use my little slope formula here because I know there's a point right here that it passes through and a point right here that it passes through. So this point right here is the point 0, and it goes up through here. Be careful. It's not in between, excuse me, it is in between 70 and 80. So this will be 0, 75. This point over here, be careful. It's 25 and 65. So make sure you count correctly. Now some of you may be thinking, well, Mr. Harrison, why'd you choose those? Those weren't one of the dark black points. You're right. Because it has to be points on the line so I can find the slope. And so I can find the y-intercept. So I'm going to do 65 minus 75, y2 minus y1, over 25 minus 0, x2 minus x1. That would be negative 10 over 25, which actually reduces to negative 2/5. And if you look at it, because I'm counting by 5s every block here and counting by 5s every block here, it's down to over 5. That only works when you're counting by the same amount on the x's and the y's. So you do need to be careful and make sure that you pay attention to what you're counting by. If you can't do negative 10 over 25 in your head, remember you can use the calculator. Do negative 10 divided by 25, press enter, press math, enter, enter, and it changes it back to a fraction of negative 2/5. Also, some of those nice little scientific calculators, even some of the ones on the that you can download on your iPad or your iPhone, will also help you out with fractions. So my slope is negative 2/5. What is my y-intercept? Now this one ends up being pretty nice because my y-intercept is right here, 0, 75. So 75 is my y-intercept. So what would my equation be? My equation would be y equals negative 2/5 x plus 75. So that means as each year goes by, the slope, or negative 2/5 there, tells me how quickly my heart rate is falling each year from a beginning amount of 75. Now that's not exactly right. The resting heart rate for younger kids is a lot higher, so we would have to do, really to get a better idea of where this would be, we'd have to do a little bit more research and find a little bit more points. But this is the basic idea here. Once you get past a certain age, your heart rate has a pretty steady decline to it. Also, this doesn't take into consideration that you could have some pretty elite athletes who have pretty low resting heart rates, not because they're unhealthy or getting old, but because they are actually healthy and their heart is very efficient at pumping the blood. So basically what you're doing today is you're just doing the same thing we've been doing over the past few classes and before spring break, and last class we did some of this. You're finding the equation of a line, but the difference is you got to draw the line that fits the points before you can find the equation. So we're going to do this 2 more times, and then I'm going to set you free for the day, and then I will post your homework probably sometime in the morning tomorrow. I'm trying to give everybody time to watch the video. So here's an example. You've got these points. We want to draw a best fitting line. Now if you want to try it on your own, you may want to draw these points on your paper, pause it, and try it first. Hopefully you had time, after you paused it, to draw your points. Now we can draw our best fitting line. Again, if you want to try it on your own, you can try it first before I go through it. But for me, my line is probably going to come up through here. Probably something close to this right here. Not perfect, but that's kind of what I see as a best fitting line. Again, I'm not saying it's perfect. We could probably sit here and argue all day long over whose line is better, but this is the one that I chose. Also notice that my line passes through this point right here and this point right here. So this point up here is the point 3, 4. This point right here is the point -2, -3. Now I can use my equation stuff that I've been doing over the past few days to find my equation. So even if you didn't get this far by yourself, try to find your equation now using these 2 points like we've been doing. So find your M and find your b. Find your slope and your y-intercept. So I'm going to find my m by doing y2 minus y1 over x2 minus x1. So that is going to be 7 over 5. How'd you get that, Mr. Harrison? Because 4 minus a negative is the same thing as 4 plus 3, which is 7. 3 plus 2, which is 5. So 7/5 is how my line is going up. Up 7 over 5. Now, this one's a little trickier because my y-intercept is not real pretty right here. So I'm going to use the point 34 over here, and I'm going to use my slope of 7/5, and I'm going to use my y equals mx plus b to find my equation. So my y value is 4, my m is 7/5, my x is 3, and I'm going to find b, find the missing b value. So I'm going to do a little bit of math in my head here, but you can use a calculator. 7/5 times 3 is 21/5. Yes, that is 4.2 if you're using decimal. You subtract 21/5 from this side. What you do to one side, you got to do to the other. You get -1/5, or yes, as a decimal, -0.2. So my final answer for my equation would be y equals 7/5 x minus 1/5 for b, my beginning amount there. So that is my y equals mx plus b. And notice it matches. My equation is up 7 over 5, and it's going through -1/5 right here, which is about 0.2 or -0.2. All right, let's do one more. So if you want to try it on your own, take a few minutes, pause the video here, copy these down onto a graph, make your best fitting line by drawing the line that fits the best. Then find your slope and find your y-intercept. Hopefully you had some time to do it. Now, obviously, I'm going to repeat myself here when it comes to the equation of the best fitting line. This is not the best fitting line. This is not the best fitting line. This is not the best fitting line. Even this right here, let's see, let's go through a couple of points there, and this one right here. Even this one, to me, is not the best fitting line. It's good, but it's not the best. In my opinion, I need to kind of move this up a little bit here. And I probably would say, maybe move that up a little bit right there to fit all the points the best. It's never going to be perfect when you're doing this by hand. Later on in intermediate algebra, or some of you that move on to maybe some algebra 1, if you waver into those classes, maybe you'll do a little bit more with the calculator and you can find an exact answer. So what we're going to do here is now take this and find our equation. Notice it goes through this point, 1, 1. Notice it goes through this point right here in particular. This is -6, 4. So -6, 4. So now I can find my slope. So my slope is y2, minus y1 over x2 minus x1. So 1 minus 4 is -3. 1 plus 6 would be 7. It goes down 3 over 7. Down 3 over 7. Now I'm going to use my slope, my m, and I'm going to use my point, and y equals mx plus b. Now I'm going to use the point 1, 1, because I think it's easier. Plug in 1 for y. Plug in -3 over 7 for m. Plug in 1 for x, and then I'm going to find my b. So -3 over 7 times 1 is -3 over 7. So that one doesn't change. Add 3 over 7. I'm going to save a little bit of space here. If I add 3 over 7 to 1, that's going to be 10 over 7. 3 over 7 plus 7 over 7. That means my equation would be y equals -3 over 7x down 3 over 7. plus 10 over 7. Now 10 over 7 is approximately, oh goodness, that'd be about 1.4 something, or about 1.3 something, 4 something. Look right here. That's where it crosses the y-axis. 1.4, 1.3, somewhere around there. So this would be my equation of my line. So you find the m, you find the b. Now, if you forgot how to find equations of lines, you may want to go back and watch some of the previous videos that I gave you. This one is mainly how to just find for best fitting lines. So, that's your lesson for today. I'll post your homework later. Miss you guys.